Hey guys, welcome back. I hope you had a great weekend. At this point, we are going to move on to Chapter 12. As far as Chapter 11 goes, we will, at least at this point, not have a test on it. I will probably continue to throw some questions from Chapter 11 onto your homeworks occasionally. But as of today, we will be starting the first section of Chapter 12. Chapter 12 deals with the volume of some different shapes, and you'll find all the materials for it, of course, in the Chapter 12 folder at the bottom of the main Schoology page. So let me get set up, and we will start the first section. All right. There we go. All right, so as you can see, the first section in Chapter 12 deals with the volume of a cylinder. Great highlighter. Fairly easy to do. We're just going to talk about a few things. The most important thing is make sure you watch and pay attention to the examples. They will really help you with your homework, I think. So first, let me quickly talk about what a cylinder is. I call a cylinder a can of soup because a soup can or a soda can is in the shape of a cylinder. Technically, it is a three-dimensional object whose top and bottom are the same size, circles, and because they're the same size, they are said to be congruent. Congruent just means they are equal in size to each other. In a cylinder, there's a name for the top and bottom. They are both called the bases. So a cylinder has two bases, both the top and the bottom. And they are connected by a curved surface, which if you took off the top and bottom and you unraveled it, it would make a rectangle. Now if you have a soup can with like a Campbell's soup wrapper on it, if you cut off the wrapper, you will see that it is actually just a rectangle that wraps around the circular can. All right, so that's what a cylinder is, and all we are concerned about today is how to find its volume or other dimensions. So I have the volume formula for you here, but first I want to talk about a circle. So the top and bottom, of course, are a circle, and one of the important things to know about a circle, and maybe you already know this, is how to find its area. Did you know that the area of a circle is equal to pi times the radius squared? All right? So what is the radius of a circle? The radius of a circle is a segment that goes from the edge to the center. So this would be the radius of a circle. And this thing, of course, would be the base. And then I guess there'd be another base down here. The two circles are called bases. The height of the cylinder would be this dimension here. And so now you have it all. But the important thing here was making sure you know the radius goes from the center to the edge. When you put two radiuses together, you get the diameter, and I'll show you about that in a second, if you're not sure already. So the volume of a cylinder, what is its formula? Well, its formula is the area of the circle times the height. Well, the area of the circle is this right here. It is pi times the radius squared. So the volume is pi times the radius squared times the height. That is the formula we can always use to find the volume of a circle. And one more note is that volume is measured in cubic units. So when you put the units on it, you want to have a little exponent of 3, which means cubic units on there. Alright, so we're going to use this formula in a couple examples, and we'll be finished here. So first up, we've got this example here. What is the volume of the can pictured below? And we're going to answer two ways. We're going to answer using pi, and we're going to answer to the nearest tenth. And I want to make sure you know how to do both of those things. So first up, let's examine this cylinder. One of the things, of course, we need to find the volume is the radius. And in this case, we were not given the radius. Here we were given the diameter. The diameter is the length all the way across a circle. And sometimes they'll do this in an example. They'll give you the diameter instead of the radius, but of course the radius is easy to figure out if you know the diameter, because the radius just starts at the middle and goes to the edge, and it would be half of the diameter. So if the diameter is 6, then the radius would be 3. And now we can simply use our formula. The volume of a cylinder is pi times the radius squared times the height. And all we need to do is substitute our numbers in. Now in this first one, we're going to leave pi, it says, in the example. So the volume would be pi times the radius squared, which would be 3 squared, times the height, which would be 12. And if we simplify that, we would get pi times 9 times 12. Or when we finish simplifying it, we would do 9 times 12. And 9 times 12 is 108. And we would get 108 pi inches. Now that is how we leave pi in the answer. This actually gives us the exact answer, 108 times pi. As you know, pi is an irrational number, which means it's a decimal that goes on forever. And if you want to give the exact answer, which sometimes you're required to do, you just simply leave pi as part of your answer like that, and you give the answer with pi as a number in there. However, a lot of times we want to approximate the answer, like in this case to the nearest tenth. And when we do that, we go ahead and we replace pi with 3.14, and we calculate it out. And in this case, when we multiply 108 times 3.14, we get 339.12. But since the directions asked for us to do it to 1 decimal place, which was the nearest tenth, we will simply make it 339.1 cubic inches. And I forgot the cubic on the other one. Shame on me. So those would be our answers. We have found the volume of that cylinder. All right, in the second example, we're given the volume, and we want to find another dimension. It says a company is designing a can for a new green iced tea. The volume of the can will be 15 cubic inches, so here's the volume. If the height of the can needs to be 4 inches so that it fits on the shelf, then to the nearest tenth of an inch, what would the radius of the can need to be? So we have this formula, volume equals pi times radius times squared times the height. And this formula has 3 variables in it, right? Pi is not a variable. Pi is actually a number. But it's got 3 variables in it. And if we know 2 of the 3 variables, we can substitute them in and we can solve for the third one. And in this case, we do know 2 of the 3 variables. We know the volume needs to be 15. And we have pi. And we do not know the radius, but we do know the height. The height needs to be 4. So now I've gotten rid of all the variables, and I can solve for r, the radius. And the first thing we would want to do, and I probably should have done this first, is replace pi with 3.14. Then I'm going to multiply the 3.14 and the 4 together. And when I do that, I get 12.56 times the radius squared. And then I would go ahead and divide both sides by 12.56. And when I do 15 divided by 12.56, I get about, let's move up here, I get about 1.194 equals the radius squared. And so how do I get rid of the square now so that I can solve for the radius? I get rid of the square by taking the square root of both sides. And when I take the square root of my previous answer, I get about 1.09. So I'm going to go ahead and call that 1.1, since I'm, I believe, rounding to the nearest tenth. And I need the radius of this can to be 1.1 inches. And that is how I would solve for a variable other than the volume. All right? Good luck with the homework.